Welcome to Section 1, Introduction, the Power of Enterprise JavaBeans. Enterprise JavaBeans, or EJB, is a powerful technology for building robust, scalable, and secure enterprise applications in Java. EJBs simplify the development process by providing a set of reusable components that handle common enterprise application concerns such as transaction management, security, and concurrency. By leveraging EJBs, developers can focus on building business logic instead of reinventing the wheel for these complex aspects of enterprise applications. Imagine building a large-scale e-commerce platform. You need to manage user accounts, process orders, handle inventory, and ensure secure transactions. Building all of this from scratch would be a daunting task. EJBs provide pre-built components for handling these common requirements, allowing you to focus on the unique aspects of your application. EJBs are designed to be modular and reusable. You can assemble different EJBs like building blocks to create complex applications. This modularity makes your applications easier to maintain and extend over time. As your business requirements evolve, you can easily add or modify functionality by plugging in new EJBs or updating existing ones. In today's rapidly changing business environment, agility and time to market are crucial. EJBs accelerate the development process by providing a framework for building enterprise applications quickly and efficiently. By using EJBs, you can reduce development time, lower costs, and get your applications to market faster. This allows your business to stay ahead of the competition and respond to new opportunities swiftly. Now, let's dive into Section 2, Understanding Enterprise JavaBeans. Enterprise JavaBeans are server-side components that encapsulate business logic and data persistence. They run within an EJB container, which provides a runtime environment that manages the lifecycle of EJBs and offers services such as transaction management, security, and concurrency control. The EJB container acts as an intermediary between the EJBs and the underlying Java EE server, shielding the EJBs from the complexities of the server environment. EJBs are based on a distributed component model. This means that EJBs can be deployed on different servers and accessed remotely by clients. This distributed architecture allows you to build scalable and fault-tolerant applications that can handle a large number of users and transactions. The EJB container handles the complexities of communication between clients and EJBs, ensuring seamless interaction across distributed environments. To use EJBs, you need to define them using Java interfaces and classes. The EJB container uses these definitions to create and manage instances of your EJBs. You can then access these EJBs from your client applications using Java RMI, remote method invocation, or other communication protocols. The EJB container handles the underlying communication details, making it easy for clients to interact with EJBs regardless of their location. EJBs provide a powerful abstraction for building enterprise applications. They encapsulate complex logic and data access behind well-defined interfaces, making your applications more modular, maintainable, and scalable. By leveraging EJBs, you can build robust and flexible applications that can adapt to changing business requirements. Welcome to Section 3, Types of Enterprise JavaBeans. Enterprise JavaBeans come in various flavors, each tailored for specific tasks within an application. The primary types are Session Beans, Message-Driven Beans, and Entity Beans. While Entity Beans have been superseded by the Java Persistence API, JPA, in modern Java EE applications, understanding their role provides historical context and a deeper appreciation of the evolution of EJB technology. Session Beans are workhorses, designed to implement business logic and workflows. They can be stateful, maintaining conversational state with a client, or stateless, handling each client request independently. Consider a shopping cart in an e-commerce application. A stateful session bean could manage the cart's contents for a particular user, while a stateless session bean could handle individual product searches or order processing. Message-driven beans excel at asynchronous processing. They consume messages from message queues, enabling decoupled, event-driven architectures. Imagine a system that processes orders as they arrive. A message-driven bean could listen to an order queue, retrieving and processing each order asynchronously, without blocking other application components. Entity beans, now largely replaced by JPA, were used for representing persistent data, mapping Java objects to database tables. While no longer the preferred approach, their legacy highlights the shift towards more flexible and efficient persistence mechanisms in Java EE. Understanding the different types of EJBs is crucial for choosing the right tool for the job. Whether you need to implement business logic, handle asynchronous events, or manage persistent data, EJBs offer a powerful arsenal for tackling diverse enterprise application challenges. Moving on to Section 4, the EJB Container and Component Model. The EJB container is the heart of the EJB architecture. It provides a runtime environment for EJBs, managing their lifecycle, providing services like transaction management, security, and concurrency control. Think of it as a specialized operating system for EJBs, handling all the low-level details so developers can focus on business logic. The EJB component model defines how EJBs are created, deployed, and managed within the container. It specifies the roles of different components, including the EJB itself, the container, and the client. This model ensures a consistent and predictable behavior for EJBs, regardless of the specific implementation or vendor. The EJB container acts as an intermediary between EJBs and the outside world. It handles communication with clients, manages transactions, enforces security constraints, and provides other services. This frees EJBs from dealing with these complexities, allowing them to focus on their core business logic. The container also provides a layer of abstraction between EJBs and the underlying Java EE server. This means that EJBs can be deployed on different servers without code changes, making them highly portable and adaptable to various environments. The EJB container and component model are essential for understanding how EJBs work. They provide a robust and standardized framework for building, deploying, and managing enterprise Java applications, ensuring scalability, reliability, and maintainability. Configuring EJBs involves specifying their properties and behavior. Traditionally, this was done using XML deployment descriptors, but modern Java EE embraces annotations for a more streamlined and developer-friendly approach. Annotations are metadata tags embedded directly in the Java code, making configuration more concise and less error-prone. Imagine defining a stateless session bean. With annotations, you simply add @stateless above the bean's class declaration. This tells the EJB container that this bean is stateless, handling each client request independently. No need for verbose XML files, keeping your code cleaner and more readable. For more complex configurations, annotations can be combined with XML descriptors. For instance, you can use annotations to define basic bean properties, and then use XML to specify security roles or transaction attributes. This hybrid approach balances conciseness with flexibility, allowing you to choose the best method for each configuration aspect. Whether you prefer annotations or XML, the goal is to define how your EJBs interact with the container and other components. Clear and accurate configuration is crucial for ensuring your EJBs function as expected, handling transactions, security, and other aspects correctly. Modern Java EE emphasizes annotations for their convenience and readability, but understanding both annotations and XML provides a comprehensive view of EJB configuration options. Choosing the right approach depends on the complexity of your application and your personal preferences. In enterprise applications, transactions are crucial for maintaining data consistency and integrity. A transaction is a sequence of operations that are treated as a single unit of work. Either all operations within a transaction succeed or none of them do. This ensures that data remains consistent even in the face of errors or failures. EJBs provide built-in support for transactions, simplifying the development of reliable and data-consistent applications. The EJB container manages transactions, ensuring that all operations within a transaction are executed atomically. This means that if one operation fails, the entire transaction is rolled back, preventing data corruption. Consider a banking application where you need to transfer money from one account to another. This operation involves multiple steps: deducting money from the source account, adding money to the destination account, and updating transaction logs. With EJB transactions, you can ensure that all these steps are executed as a single unit of work, guaranteeing data consistency. EJBs offer different transaction management strategies, including container-managed transactions and bean-managed transactions. With container-managed transactions, the EJB container automatically handles transaction demarcation, while bean-managed transactions give developers more fine-grained control over transaction boundaries. EJB transactions are a powerful tool for building reliable and data-consistent enterprise applications. They simplify transaction management, freeing developers from the complexities of handling transactions manually and ensuring data integrity even in complex scenarios. Section 7. EJB Security, protecting your applications. Security is paramount in enterprise applications, especially when dealing with sensitive data or critical business processes. EJBs provide robust security mechanisms to protect your applications from unauthorized access and malicious attacks. The EJB container integrates with the Java EE security model, allowing you to define roles, permissions, and access control rules for your EJBs. Imagine a healthcare application that stores patient records. You want to ensure that only authorized personnel can access and modify this sensitive data. With EJB security, you can define roles like doctor, nurse, and administrator, each with specific permissions for accessing patient information. EJB security is based on declarative security, where you define security constraints using annotations or XML descriptors. The EJB container enforces these constraints at runtime, preventing unauthorized access to your EJBs. This declarative approach simplifies security management, allowing you to focus on defining security policies rather than implementing complex security logic. EJBs also support programmatic security, allowing you to implement custom security checks within your EJB code. This gives you more fine-grained control over security, enabling you to implement complex security rules that go beyond basic role-based access control. Whether you choose declarative or programmatic security, EJBs provide a comprehensive framework for protecting your applications. By leveraging EJB security mechanisms, you can ensure that your applications are secure, protecting sensitive data and critical business processes from unauthorized access. Section 8. EJB and Java EE integration. EJBs are an integral part of the Java EE ecosystem, seamlessly integrating with other Java EE technologies to create a comprehensive platform for building enterprise applications. This integration allows you to leverage the full power of Java EE, combining EJBs with technologies like servlets, Java Server Pages, JSP, and Java Message Service, JMS, to build complex and feature-rich applications. Imagine building a web application that uses EJBs for business logic and JSP for presentation. You can easily connect your JSP pages to EJBs, allowing your web interface to interact with the underlying business logic and data. This integration enables you to create dynamic and interactive web applications that leverage the power of EJBs for handling complex business processes. EJBs also integrate with JMS, allowing you to build asynchronous, message-driven applications. You can use message-driven beans to consume messages from JMS queues, enabling your EJBs to react to events and process data asynchronously without blocking other application components. This integration opens up new possibilities for building scalable and responsive applications that can handle a large volume of messages and events. The tight integration of EJBs with other Java EE technologies provides a powerful and flexible platform for building enterprise applications. This integration allows you to combine the strengths of different technologies, creating a synergistic effect that enhances the capabilities of your applications. By leveraging the full potential of Java EE integration, you can build robust, scalable, and feature-rich applications that meet the demands of modern enterprise environments. Section 9. Advantages of using Enterprise JavaBeans. Using Enterprise JavaBeans offers numerous advantages for developing enterprise applications. EJBs provide a structured and robust framework that simplifies development, enhances maintainability, and promotes scalability. By leveraging EJBs, you can build high-quality applications that are easier to manage, adapt, and extend over time. EJBs promote code reusability, allowing you to create modular components that can be used in different parts of your application or even in other applications. This modularity reduces development time and effort, as you can reuse existing components instead of rewriting code for common functionality. The EJB container handles many complex tasks, such as transaction management, security, and concurrency control, freeing developers from having to implement these aspects manually. This simplifies development, allowing you to focus on business logic rather than low-level technical details. EJBs are designed for scalability, allowing your applications to handle increasing workloads and user demands. The EJB container manages the lifecycle of EJBs, creating and destroying instances as needed to optimize resource utilization and ensure responsiveness even under heavy load. By leveraging EJBs, you can build applications that are robust, scalable, and maintainable. The structured framework, built-in services, and focus on reusability make EJBs a powerful choice for developing enterprise applications that can meet the demands of modern business environments. Section 10. Conclusion. EJB, a cornerstone of enterprise applications. Enterprise JavaBeans have proven to be a valuable technology for building robust, scalable, and maintainable enterprise applications. While certain aspects like entity beans have evolved, the core principles of EJBs remain relevant in modern Java EE development. Their ability to handle complex concerns like transaction management, security, and concurrency control frees developers to focus on delivering business value. The evolution of EJBs reflects the changing landscape of enterprise software development. The shift towards annotations for configuration and the integration with powerful technologies like JPA demonstrate the adaptability of EJBs to new paradigms and best practices. EJBs continue to be a cornerstone of enterprise application development in Java. Their ability to encapsulate business logic, promote reusability, and provide a structured framework makes them an essential tool for building high-quality, scalable, and maintainable applications. As enterprise needs evolve, EJBs are likely to adapt and remain a relevant force in the Java ecosystem.